Hello, it's all about circle today. Circle, we are following formulas that you must know. Number one, if we draw tangents from an exterior point to the same circle, then the length of the tangents will be always equal. This is the first formula. Whenever you will find and you will see two tangents are coming from an exterior point to the same circle, their lengths will be always equal. PA is equal to PB. If someone asks me how to prove it, we have congruency. It's very clear. Tangent always makes 90 degree with the tangent. Radius and tangents will form always 90 degree. This is the notion of tangent. Now you see, this is 90 degree, this is common, hypotenuse is common, and radius is equal. OB is equal to where both are radii. So definitely by RHS these two triangles are congruent. CBSE will tell you PA is equal to PB. This is the first formula. If any tangents coming from an exterior point to the same circle, they are equal. Number two, angle produced at the center with the radii and the point of contact A and B. The radii are centered to the point of contact. If it is there, then angle AOB plus angle APB is 180 degree. Why? Because this is a quadrilateral and sum of the quadrilateral is 180, 360 degree, right? Now these two are 180 degree, 1990. 360 minus 180, it is 180. So APB plus AOB is always 180 degree. This one, APB plus AOB is always 180 degree. This is the second formula. Third one, APO and BPO equal, bisector. PO is the bisector, CBSE. We have proved already these two triangles are congruent. So these two side radii are equal, opposite to these are these two angles, and tangents are equal, opposite to these tangents are these two angles. So APO is equal to BPO. These two angles are equal. Same way, these two angles are also equal, AOP and PO. This is the third formula. Now we have got it. Any tangents are coming from an exterior point, they are equal in length, number one. And the angle produced between them and with them, if we join and complete this quadrilateral, the sum of these two angles, AOB and APB, is also 180 degree, and these two angles are bisected by PO. Third. So now we have again here also. This is fourth one, and this is fifth one, and this is sixth one. Fourth one is this angle, I mean this one, is double of this angle. Why it is so? You see, I told you APOB and AOB is 180 degree. In this quadrilateral APBO. Now, in this triangle ABO, the sum of the angles of a triangle is also 180 degree. Now, this is an isosceles triangle because these two sides are equal radii. So obviously, this angle plus twice of this angle will be 180. That means what I want to say, angle AOB plus angle twice of angle BAO is 180 degree. Number one, because here this sum of angle of this triangle ABO is 180 degree, and these two angles are also equal, so I may use this one, twice of this angle together. So this is this one. And we have this relation also. This is also 180, this is also 180. So therefore, angle AOB plus angle 2BAO is equal to angle APB plus APB plus angle AOB. So definitely AOB is also 180 degree. These two angles are 180 degree. This is also sum of 180 degree. So AOB cancels out. APB, this angle is equal to twice of BAO. This angle, double of this angle will be always equal to this angle. This is the fourth one. The fifth one is, I have already told you PO bisect these two angles. Because we have come to know these two angles. These two angles are equal, these two angles are equal, so this PO is the bisector of these two angles. This is one. And sixth one is very important for finding the length. I will show you problem where it will be also used. AMO, I mean AOP, APO, and PAO. The angle PAO and angle AMO. These two are similar. Why? This angle is 90 degree of this small triangle, and this bigger one, this is 90 degree. Now this is common, so obviously this angle is equal to this angle. I will use similarity for this triangle to find length, and I will just put questions now. Okay. Now questions related to tangents from an exterior point of the same circle. That is the first formula that we have come to know. Here you see the question will be like this. PT and PQ are tangents to the circle of center at O. And AB is also the tangent at M. So therefore PAB is a triangle. This triangle, its sides are externally touching the circle. Like if you produce this, it will touch here. If you produce this PB, it will touch at Q, and this side is also touching at M. So definitely we will face this question. Perimeter of APB is twice of either PT or P. Because PT and PQ, you know, these two tangents are equal from an exterior point to the same circle. Here also this is an exterior point, AT and AM are also equal. And here BM is also equal to B. So, what we have? Triangle PAB. Perimeter of this triangle PAB is your AP plus PB plus AB. Now, since we have a chance to split this one, here we will split AB into AM plus MB. AB is nothing but AM plus MB. Here again, we know this is an exterior point and these two are tangents. AT is equal to M. So, this is also M. M is equal to AT is equal to M. So, we will change M into AT and MB into BQ. Now, if we add AP plus AT, this will be PT. And if we add PB plus BQ, this will be PQ. So, AP, PT plus PQ, PT plus PQ, PT plus PQ. Now, PT and PQ both are equal. So, either this will be PT plus PQ is either 2PT or 2PQ. So, the perimeter of the triangle will be always double of this tangent, two greater tangents. Here we have. Okay. Now you see these as triangle externally touching a circle. For this perimeter of this triangle will be always twice of this tangent greater triangle, either this PT or PQ, because both are equal. Okay. Now here a circle is internally touching a quadrilateral. In this case, again we have the same identity, the same formula, that is tangent from an exterior point to the same circle are equal in length. We will use it and we will get it here. Sum of opposite sides are equal of a quadrilateral if a circle is inscribed in it. If a quadrilateral is inscribing a circle and touching at this E, F, G, H, we can prove AB plus CD is equal to AC plus BD. That means sum of opposite sides are equal of a quadrilateral that is inscribing a circle. Inside it there is a circle and touching the all sides. Now you see AB, we can change AB into H plus HB, H plus HB, and CD we can change into CF plus FD, CF plus FD. Now CF will be, C is again tangents, CF is tangent and C is and these two tangents are also equal. So we can change this all, like AH into AE, BH into BG, CF into CE and FD into FD. That's what we have changed here. H into AE, BH into BG, CF into CE and FD into DG. Now if I add AE plus C, AE plus C, this is nothing but AC. So this is AC. This side. Again, if I add BG plus DG, BD, BG, DG, this is DG and this is BG. BG plus DG. If I add BG plus DG, this will be BD. So AC plus BD. So in this case, sum of its opposite side will be always equal. AB plus CD is equal to AC plus BD. So you remember this one and try to use this one. If when circle is touching this way, like triangle, its all sides are touching externally a circle, then we have this relation. Perimeter of this triangle will be half the length of the greater triangle. Perimeter. We double of this greater tangent. Okay. Hello. ABCD is a quadrilateral, ABCD is a quadrilateral such that angle D is not D. A circle C, center at O and radius R, touches the sides of this quadrilateral. At point AB at P, BC at Q, CD at R and AD at S. The lengths are also given. BC given, DC given and PE given. You see? You have to find out the radius of the circle. Here you have the clue. This PB is given. This PB is given. We know B is an exterior point. So BQ is also 27 centimeter, right? Here we have. Here we have PB is equal to BQ. So PB is 27, so BQ is also 27 centimeter. Now you see, BQ is 7 PB, BQ is 27, then CQ is what? CQ is, therefore CQ is BC minus BQ, and that is your 38 minus 27, 11 centimeter, right? If CQ is 11 centimeter, CQ, now this is C is an exterior point and Here these two CQ and CR are tangents, so definitely CR is, or therefore CR is also 11 centimeter. Now if 11 centimeter CR is there, so what is dr? So dr is what? Now dr is equal to DC minus RC or CR. DC is what? 25 minus CR 11. This is 14 centimeter. And dr, what is asked? Find the radius. And dr is the radius. But do remember, here you have to give a reason. See, angle AC is 90 degree, D is 90 degree, R is 90 degree, it's a quadrilateral, so obviously this is also 90 degree, so it is, and the adjacent sides of a quadrilateral are equal and all angles are equal, so it is a square. You have to say, since S is equal to D is equal to R is equal to 90, therefore, and OS is equal to OR is equal to R, therefore SO RD is a square, right? Therefore, dr is R, so R is 14 centimeter. This is also the same type of problem like here. ABC is a right angle at B such that BC is 6 centimeter and AB is 8 centimeter. Find the radius of the circle. See, here also the same reason and same question, same type of that was earlier quadrilateral, it is a triangle. But here also the CP is 90 degree tangent, BQ OQB, this is also 90 degree, and this is given 90, so this is also 90, and these adjacent sides are equal, you have to say. So OPQB OPBQ is a OPBQ is a square. Therefore, BQ is equal to radius. If BQ radius, PB is also radius, this is also radius, so definitely this is also radius. Now here you have to use once to find AC with the help of Pythagoras Theorem. Perpendicular AB is 8, BC is 6, so by Pythagoras, in triangle ABC, AC square is equal to AB square plus BC square. You can easily find out AB is 8 square plus 6 square, this is AC square, and this is nothing but AC square is equal to 100, so AC is equal to 10 centimeter, right? Once you have 10 centimeter AC is here, AC is equal to what? RC plus AR. Now we know AR is equal to AP, this is P, AP, this is your P, no? This point is P. Now AR is equal to AP, and here this is the tangent again, these two are the tangents, CR is equal to CQ, CR is equal to CQ, okay? Now CQ is what? CQ is 6 minus R. CQ is what? BC minus BQ, that is 6 minus R. And what is AR? AR is equal to AP. AR is equal to AP. So AR is, AP is what? Now 8 minus R. Okay? Now if you take the CQ is equal to CR. So I can write here this CR. Okay? CR is your 6 minus R. And AR is also 8 minus R. Sum of these two will be AC, that is 10. Now we have 6. Now we have 6 minus R, CR. We know CR plus AR is equal to AC. Now shear is what? Shear is 6 minus r plus this is 8 minus r is equal to 10. So it is your 14 is equal to 10 minus plus 2r, or 14 minus 10 is equal to 2r, 4 is equal to 2r, r is equal to. So r is equal to 2 centimeter. You got it? This is all about the tangents, the relation that we have. I will come with more problems, but please try to practice this sum as many as you can. This is for your aid, and I do hope if you follow, you will be definitely having very supportive these materials for your exam.